Today we are going to learn about mastering Boolean indexing in NumPy. You will discover how to efficiently use Boolean conditions to extract, modify, and analyze specific data elements, a skill crucial for data analysis and machine learning.
Welcome to our video on mastering Boolean indexing in NumPy. Boolean indexing is a powerful technique used in data analysis and machine learning, allowing for efficient data manipulation. Understanding Boolean indexing is crucial because it enables you to extract and modify specific data elements efficiently. Today, we will guide you through the process of applying Boolean conditions to data arrays, which will enhance your ability to perform complex data operations. By the end of this session, you'll be equipped with the skills to use Boolean indexing effectively in your data analysis tasks. In this section, we delve into creating Boolean arrays using conditions. A Boolean array is an array of Boolean values, typically generated by applying a condition to a NumPy array. For instance, consider an array of numbers and a condition that checks if each element is greater than a certain threshold. The result is a Boolean array where each element is either true or false, depending on whether the condition is met. This is powerful because it allows us to easily filter and work with subsets of data. We'll explore practical examples, such as filtering out values above a certain threshold or selecting specific data entries, to provide a clear understanding of how these arrays are constructed. Boolean arrays are incredibly useful for filtering data. Once you have a Boolean array, you can use it to filter your original data array, extracting only the elements where the Boolean array is true. This is particularly useful in data analysis, where you may need to focus only on data points that meet specific criteria. For example, in a dataset of customer transactions, you might use a Boolean array to select transactions above a certain value. This filtering process is efficient, leveraging NumPy's optimized operations to handle large datasets quickly. In this section, we will walk through several examples to illustrate how Boolean arrays simplify the task of data filtering, making it both faster and more intuitive.
Boolean indexing is not only about filtering data, it's also about modifying it. With Boolean indexing, you can change specific elements of an array based on conditions. For instance, if you want to set all elements below a certain threshold to 0, a Boolean array can identify these elements, and you can modify them in place. This technique is especially useful for cleaning data, preparing it for analysis, and optimizing machine learning datasets. We'll demonstrate how to perform these modifications using real-world examples, emphasizing the efficiency and simplicity of Boolean indexing for making targeted changes in large datasets.
In many scenarios, you'll need to apply multiple conditions simultaneously to your data. Boolean indexing allows you to combine these conditions using logical operators like and, or, vertical bar, and not, tilde. This capability enables more complex data filtering and manipulation tasks. For example, you might want to extract data points that are within a specific range or meet multiple criteria at once. By combining conditions, you can create sophisticated filters that allow for nuanced data selection. We'll explore how to apply these logical operators in practice, illustrating how they simplify the process of working with complex data requirements. One of the key advantages of Boolean indexing in NumPy is its performance efficiency, especially when dealing with large datasets. NumPy is designed for high-performance operations on arrays, and Boolean indexing leverages this capability. By using Boolean arrays, you can perform data filtering and modification tasks much faster than using traditional loops or list comprehensions. This is because NumPy operations are implemented in optimized C code, allowing for significant speed improvements. In this section, we will discuss how Boolean indexing can drastically reduce computation time, improving your data processing workflow, and enabling you to handle large datasets with ease. While Boolean indexing is powerful, it's important to be aware of common pitfalls that can lead to errors or unexpected results. One frequent mistake is using the wrong logical operators, such as using an instead of and. Another common issue is misaligned arrays, where the Boolean array does not match the shape of the data array. To avoid these pitfalls, it's essential to double-check your conditions and ensure that your Boolean arrays are correctly constructed. We'll provide tips on how to debug common issues and share best practices for using Boolean indexing effectively, helping you to avoid these common traps and ensure accurate data manipulation.
To truly understand the power of Boolean indexing, it's beneficial to see how it's applied in real-world data analysis tasks. In this section, we'll explore practical examples and case studies where Boolean indexing plays a critical role. From cleaning and preparing data for analysis to extracting insights and optimizing machine learning datasets, Boolean indexing is a versatile tool. We'll demonstrate how it can be used to streamline data cleaning processes, select meaningful data subsets, and enhance the efficiency of machine learning models. These examples will provide you with a clear understanding of how Boolean indexing can be applied to tackle real-world data challenges. Thank you for joining us in this exploration of Boolean indexing in NumPy. We've covered the essential techniques for creating and using Boolean arrays, discussed their performance benefits, and highlighted common pitfalls to avoid. Boolean indexing is a powerful tool that plays a crucial role in data analysis and machine learning, enabling efficient data manipulation. We encourage you to practice these techniques and apply them to your own data projects. As you continue to explore NumPy and its capabilities, Boolean indexing will undoubtedly become an invaluable part of your data analysis toolkit.